So the output we have here is libraries. DLS in Windows, SO in Linux. And these libraries are the simulation modules, are the how the square is moving, how the triangle is moving, how the plane is flying, for example, etc. And also we have code here incorporated for controlling that with a state machine, for saying, okay, now stop, now give me the next step. And also we have code for acting as a factory, for saying, okay, give me a new copy of the plane with different parameters. And later we will see how we use that. Okay, so now we have the Simware sync with the data model, and we have the simulation modules. Now we go to GPW. What is GPW for? Okay, well, at the end we are going to control everything. We want to control the simulation. We want to stop the simulation. We want to run the simulation. And we want to be able to create instances of the simulation modules. And for doing the trick, we have this tool that is called ACS. Okay, let's open ACS. Well, we can close Modeler. If we open ACS, that is installed with the product, now we open it, and we can see that there is no state machine at all, and there are no objects here. Why? Because ACS is generic, doesn't know a thing about what is the simulation about, doesn't know a thing about what are the objects in the simulation. This is a good thing because we can use the same tool, the same ACS, for any simulation. Well, this information will be provided to ACS using the scheduler and the configuration file, and we will show that later. In the configuration file, we have the information about how what elements are in the simulation. Well, but then ICS has a problem because, okay, so the files gives me the information about that and says, okay, you are dealing with something called circles, but what are the initial conditions of these circles? So we need to create something that is called a panel, and a panel that is the output of GPW, by the way. A panel is just the information about the initial conditions of the objects of the simulation modules in the simulation. So GPW is used for that. It's for creating these so-called panels. So if we open GPW, what we have here is that we can read this XML of the initial conditions of the entities. So we load that, for example, for the output directory we used before. And we have here is the representation of the initial conditions, as we declare that in the modeler tool. Sorry. And here we can give that a initial value. We can say, okay, this is 34, and the range, the valid range will be up to 80, and the units will be meters per second. Okay, the units are something decorative, can be anything, can be, for example, parsecs per minute. What is really useful is the default value and the range, because this tool is going to check this range and to use the default value if you don't put any other value. And this is very, very interesting. So now you can generate the panel. At the end, we are going to generate two things, by the way, a library and an XML file. So we generate the panel. Well, we need a place to put the result, and we need the data model. Which data model? The same data model we have here, the same thing we have here. So we can go here and say that this is the directory of the data model. So we generate and build that. Okay, let's go here and see what is happening. Well, it has created a thematic list. It has created some code, and now it's compiling, or is going to compile that code. Well, it's created a solution, compiling it, etc., etc. And what we are going to have at the end? We are going to have a well, it's building it. We're going to have a library that is the physical panel that we will see in the ACS with the values that we put in the GPW tool. These values are in this file. We have the default value, we have the minimum, the maximum, and the units we put in the GPW. This is very useful because we separate the physical panel for this information. So if you want to modify this information, you can do it modifying this file without having to recompile the panel. Okay, so this is compiling, has finished, and voila, we have here the DLL, which is the panel itself. At the end, this is the visual panel that the ACS will see, and we will see that in an example in a moment. Okay, so this is finished. Okay, so now we have all the process, the modeler, and Simware sync with the data model, the modules ready to be used, and the GPW providing the panels to the ACS. So now we can run the show. And for running the show, we are going to use eHost. eHost is a scheduler and sim engine. I'm not going to enter into detail. Well, the idea of eHost is that eHost is agnostic to the model. And the information about the real thing, about what we are doing at the end, is in this configuration file. The configuration file is the logical layout of the simulation. Is the only place where we decide what to load in which element. We are not talking about physical layout here because we are in distributed simulation. I mean, things can be anywhere. We are just saying in this file, okay, you an element with that name, and I don't care if you are here or not, or where are you will have to load this and that library. And this configuration file also will say, okay, you ACS will deal with these entities. So let's see this file. We have an example also here in the installation. We open it. Well, first we have the logical layout of the simulation. We say, okay, we have one scheduler, only one. We can only have one scheduler for the entire simulation. And well, the frequency will be 50 Hertz. This means that during runtime, this will send information with that, sorry, not send information, send ticks to the modules using this frequency. And here we're saying, okay, here we have two simulation engines. I don't care where are you. I don't care if you are really here or not. But if you are there, you will be responsible of dealing with these simulation modules I have created before. The circle and the square, for example. And I can say, okay, this module has a frequency of 20 Hertz. This is important. I can put any frequency that is less or equal to the main frequency of the simulation. Other things important here, I can decide, for example, the order of execution. Just in case maybe this circle needs the square to be run before or the other way around. And also I can say things like warm-up cycles. How many cycles do you need for putting the modules in the right start position? Well, here we have the information for the ACS. We are saying, okay, ACS, in this particular case, look for panels for these entities, circle, squares, and triangles. And these uh, libraries has been created with GPG.